complex title, we will talk about simplifying things. So what it is about, in the past, someday I had to fix some problem, and after some time I found that the place when it was possibly broken, the code was very complex, and it looks like something obviously wrong, but it was very hard to fix it because when I changed that, it broke something else. So I tried to use the git blame to check what was the last commit touching that, and it was very surprising because it was me, but many years ago. So it was I didn't remember that, and also I didn't have any information in the commit message or maybe unit test or any documentation. So I started to think how to not do this again. And yes, if we are in this place, only thing which left was just reading the code and checking what it does and what it impacts, but it takes a lot of time. So it would be very nice to improve that, because when we look at some unknown code, it is not always very easy to know what it does. We don't know if it is some physics calculation or I don't know, a printer driver. And when it contains a lot of magic numbers, a lot of parameters, using different modules, and everything is mixed together, it's hard to say. So when we look at some functions, it's not obvious what it does. And like in this example, it's quite short function, but it does very complex things, and probably small details matter. And if we change some small thing, it can have a big impact. So I was wondering why it is hard to understand and how to improve. And in fact, it's not only a problem in programming, but the general rule for all the complex and growing systems. For example, we can take the New York City public transport network, and we see that it's very old, one of the oldest systems in the world. It started to operate around 1904, and it operates almost all the time, 24/7. It already has almost the 500 stations, and yes, as we can expect, it cannot be reworked because millions of people every year are using that network. So it is not possible to stop the whole city, and also it has to be repaired as soon as possible, and probably in small maintenance windows, like in the during the night, we can stop some small parts because people want to go to work next day. So if we have complex systems, very complex system, it will be always more hard to maintain, and the development and extending will be slower. Like in this plot, in this chart, I have the population on the right side of the New York City, and on the left side, the the time when new lines in the metro were started. So we can notice that it had more rapid growth in the beginning, because in this lower segment we see it's about 50 years, but the population growth was about 300, 300, oh no, 3 millions. And we have a lot of blue dots on the left side, which means that we started a lot of lines. But the upper segment, we have similar growth in population, but only few lines are added. And possibly it's because of the cost of regular maintenance, where we have to handle all these existing pieces, and we don't have resources to build new stations, refill them, and build new lines, and also buy new trains. So as I heard, there are not very fancy trains there, but rather older ones. Yes, and when we compare to the programming, it's very similar. And what's the story behind the complex code we cannot understand? In 1997, there was some popular paper, which is an extreme example of bad system, and it is called Big Ball of Math, which is anti-pattern, which describes the system which lacks the architecture. People are not considering any structure or how to refactor that code, how to fix it, but they usually just add things and remove things when there is new requirement without much thinking. And it's not because of these people who don't know how to do it, because of course they have different urgent fixes to do, and also possibly new people work on the same thing which previously was done by someone else, and it's something normal. And I think the most important part of this description is the last paragraph, which is the end result, that information is shared between very distant elements of the system, and all the information is duplicated or global or connected with every other piece of that software. And we can imagine how it happened, even if we have some simple example like login screen for the app. First, we start with something very, very small and simple. It has only login and password, but with time, we have more and more requirements. Some of them have to be, of these features have to be done very quickly, and we have to add new codes to this previous code, and not always we will think how to improve the code itself, but we just will add everything to the same object where it was done. We don't think how to split it maybe, and yes, without thinking about any previous actions and without refactoring, maybe we will copy paste pieces of code and put in other places, and we will add only the if statement, which just fixes the problem. We will probably end up with this code from the anti-pattern mentioned before. And probably we'll have some very big class which has multiple parameters and member variables, and we can in different functions change them independently, which can cause bugs. And I like to think about such classes like about very complex state machine, which has a lot of states, and some of them are some of the transitions we want to do, but sometimes by mistake we will just change some parameter, or we will forgot to change something, and we land in completely unexpected state which shouldn't be ever activated, and yes, then we have some bugs. So what we can do? I think from that, it seems that we should think about design on daily basis, and not only when we're writing completely new code first, but do some small cleanups with every pull request we do, because we cannot afford to change it later. As we know, we sometimes do some temporary changes and then they stay forever. So it will be easier to do this with the initial pull request. So we should always remember to before merging pull request to do some smaller cleanups of the code we changed. Then it doesn't impact that much the complete app, but it will improve in the longer time horizon the state of the code. And we can, how the good code looks, it of course depends on the person. I'm also not expert here, but we can imagine that if we have code which looks like spaghetti and we try to just put something on one side and find it on the other, and we don't know what is between and what happens there, then probably it's not the good code, because it can have some side effects, and we can even don't know what we can cause with that. And probably the good code will be something like Lego, where we have some small unified components which we build from smaller pieces, and they all fit together. But of course, it is not always possible. But in this talk, I would like to find some small improvements we can do, which will make that impact on the long run, but not break the uh, the uh, the work of others. Like we cannot do big reworks. So why it's important? It's important because it will help us in the future. Like in my example from the beginning, if I would put some more information, then probably it will be easier to fix it later. And it's very probable that if you did some changes and you are the last person who touched that code, someone will ask you to explain or fix the code later. So it will be easier to have that information from yourself. And also it's more fun when we have simple things to do, and because as we know, always there are unexpected problems which will still provide some additional things to do. So here I will present some small tips, and of course you can add more of them, because everyone probably knows some nice tricks. And yes, so like I mentioned, the first line of defense from that disease will be adding some documentation. So at least it will be ugly, but we will know what it does. And I think the most important documentation is the commit message, because the documentation in the code or in some files will be very quickly outdated. So the commit message is always connected to some change which happened, and it will be never updated, because it is just describing what that change did. And later on top, we can put some other change, and it also will have the commit message. So that's why I'm sometimes annoying in the reviews when I'm asked for the commit message or more explanation. And we have some nice article on the Document Foundation blog where you can find some tips how to write a good commit message. I think also there were some talks on the conference in the past, but I didn't find any videos. So at least we have this text. Yes, and about the commits, they should be as small as possible, because if we put some comments in this message, we probably want to describe some piece of the change. So it will be very useful. It will be split into some logically separate things, which we can do one after other, and not have 30,000 lines of code changed, and then it will have conflicts with everything in the code, and also nobody will be able to read this code and understand where is the change. So it is easier later to check what was changed, and also it makes the review faster, because not only the developer has to know what it does, but also when we do review, it's always hard to review some big pull requests. But if it is split into smaller commits, it's more easy, because we can just go one by one and check what it does. Also, it's very important to not join the refactor with the functional changes, because then the changes are hidden inside of these refactors. Yes, and one useful tool is git blame. You should definitely use that, because when you fix some bug and you know already the piece of code which probably is affected, it's very probable that some recent change did the bug, did the problem if bug is recent. So I like to use some plugins to code editors, where you can just click on the line, and on the right side you can see how long a time ago it was done, what was the commit message. You can hover that, and you can see the commit description. So like you can see the previous tip about the putting the commit message, not only the title, is useful here, because we can read that just line by line and see what it does. And here is example of Visual Studio Code, which has plugin like Git length, and it shows pop-up like this. Yes, and also unit tests. And they also are documentation, because even if code is very complex and hard to read, you still have some behavior you can observe described in these tests, and you can know what it should do. So it's always more safe to, or we shouldn't refactor anything without tests, because we can easily break that. And if you have tests and they fail, you will be notified, and you can fix the bug. And it's also useful to put the unit test in the same commit as the functional change, because yeah, like I said, it's documentation, so it is connected to the change probably. And other thing where comments in the code are useful, in some fundamental concepts of some modules. here is an example of our Canvas section, which has a very nice and long documentation. So if you start to work on these Canvas sections, you have to understand how it works, how the properties impact different behaviors. So you can read that, and you will have some big picture before working on that code. Without that, it will be very hard because only the author of the code would know some corner cases or some not obvious side effects. Yes, and now some small techniques of code cleanup. It's very popular that during the review, someone mentions to fix the code which was duplicated. And yes, it's very easy refactor and relatively safe. So we should do this when it's possible. If we modified some function and we already have piece of code which we will need to reuse, it will be good to put that into some separate method which we can reuse. So the code is shorter, more readable, and also it's nice because we give a name for some piece of code. So if we have long function, it's hard to understand what it does, but if it's split into smaller pieces which have names, you already have idea what it does. So we can do this extraction and giving a name for different things on many levels, like variable, if we have some if condition, or method where you have to duplicate some code, or even we can extract some bigger pieces into classes or even components we will later reuse. So it's useful to prepare a set of tools which you can later reuse. This is that Lego thing I mentioned before, that we want to build some bigger pieces, bigger components from smaller pieces. Yes, and it's this naming is very useful for complex conditions. Like sometimes we have very long conditions which have like 5 or 6 lines. It's very hard to understand what it does. And I always like to split them into some, or group them into smaller pieces. Like here we have some code for dialogues where we detect different types or other properties. On the top we have prepared some groups of conditions which are much easier to check if they are correct, and then we can reuse them to create even more complex conditions from these smaller ones. And later in the code, we can just use this alias for the very, very long complex condition. Like here we have is document area pop-up, which is defined above. And you can compare with something below. It will be probably repeated many times in the code, and it's harder to understand when it's a very long line or multiple lines, and it's better to have human readable name for that. And yes, reuse in every place. It makes the code more easy to read, and you can understand that quickly. And yes, good name is also important because we can use the Git grep to find where some variable was changed. But if it has a very generic name like state type, then the results list will be very, very long. So it's useful to add some unique name because then it is easier to find all the places where something was changed without any false positives. Yes, and the next thing is more about the object-oriented programming. Sometimes I see that we have C-style code just packed into the class, and it would be much easier to read if we could split that into a few subclasses, because it's very suspicious when some class has in every method the if-else statement or switch with the type which was assigned in the constructor, and it does different things on depending on the type. Or sometimes it has this type switch only in a few methods. Then it means that we could split that into two different types, which share some abstract parent maybe, but the one of them could be very short because it will be just the same like the first object, but it has modified only two methods, for example. So I think it reduces the complexity because the code is shorter, so it's easier to read. Yes, and other thing in in the design is mixing the abstraction levels. We could see some kind of layers in the software where we have very high level APIs, or maybe they are public APIs for which are used by other apps or components which do the big tasks. But below we have some hidden implementations, which can be maybe different depending on the operating system or the context in which we use these high-level classes. And it's not good when we use the implementation details in next to the high-level code. It's very easy to do in JavaScript because we can just access all the different objects. So in this example on the top, we can see we have some ON where we set the mode to bake, but below we just modify the very deep internal state, just forcing the temperature to 190 degrees. But we could provide the unified API and just create the high-level method, which will be much better, because then this code will not depend on some specific implementation, because we can imagine later we will rework the internals of this high-level class, and then we will not notice that it was used, the internals were used in some other file, and we just changed it, and it will be broken. So we should always be careful with that in JavaScript. And yes, also it will be useful to not use the chain of, for example, 8 different sub variables of different class. It will be useful to split that into some layers. So we will not have to type these very long sentences which are hard to read. Yes, and what I think how we can learn doing that, of course, it's the best method to learn is to try to explain someone different things like I do here. It is very useful because I have to think what to put into this presentation. So I will read some articles about that or watch the videos. And I think the best tool for learning that, like noticing the things to improve, is to read a lot of code, which is not our. So we could do reviews. It is, for example, good to also take over ownership of some code we already wrote. And good tool for that is in the GitHub. We can define some files which, after modification in any pull request by someone, automatically will assign the reviewer to some specific users. So we can be notified and assigned to review some code, which we already know, and then we can check what is changed there and just see what people do there, and maybe we can also make some recommendations how to improve that. We have already example of that, and thanks to Skyler, because we have the before Prater file, which has some ignore list inside. And we noticed that very often people add new files to that list, which is not useful because we want to follow the coding style in all the new code and only left the old code untouched. So now, if someone will modify that file, Skyler will be automatically assigned to that. And also I think me, so we can check the if someone will not add new file to that list. So maybe we can do the same for our favorite code we already wrote. And of course, there are books and a lot of conference talks in the internet, which are free to watch. So it's good to see what people recommend. And yes, there are some. The topics we can search are legacy code. There is a lot of talks about that, and also recently there is a lot of content about the domain-driven design, which is maybe not very focused on the code itself, but the design and gathering the requirements and checking how the system should work. But it is also related and probably useful. Yes, thank you. If you have any comments, maybe you know some nice things we can do every day to improve the code, please comment.
Thank you, Szymon, for a great presentation. And now it's time for questions. Andras, do you have any questions or something to add? Okay, we can't hear you, Andras. Okay, Attila.
Thank you, no questions.
Okay, Kellen.
I'm just reminded at the start about the train maintenance that when I was working in Hamburg, there was a guy whose job it was to fix the train tracks while the trains kept running. So every 20 minutes, the train came, and the train left. He'd jump in, he'd dig a hole, which was like above his head, and then somebody else's job was to blow the whistle when the train was coming, and he'd jump out of the hole. So he worked for 15 minutes,
Okay.
and he'd jump in and out of the hole as the train passed overhead. It struck me every time I looked at him. I said, "Yeah, that's kind of like my job, but without the danger, the risk of trying to keep things running at the same time as maintaining them." So yeah, I can see your analogy there. But Yeah, anyway, rambling story, but yeah, I get that.
Okay, thank you. Kellen, Szymon, do you want to add something or no? You are muted, by the way.
Oh no.
Okay. Darshan, any questions?
No questions. Thank you.
Okay, thank you, Gabriel. We can't hear you, Gabriel. Okay. I'm Mark.
Yeah, so maybe a comment that many of these suggestions also help quality assurance. So all this kind of atomic approach makes it easier for QA to investigate independently and speed things up a bit. So yeah, thanks.
Thank you. Okay, João, questions?
No thanks.
Jaume? Mevan? Mevan, questions? Okay, Mike?
Sorry, I was muted.
Yes.
Yes, I had a few things to add. How about enums and to avoid Boolean traps? Unfortunately, that's not usable in GS really, but that's something that could be we could have some tools around it. So enums are great to avoid misrepresentations of Boolean, because a bool is just one or false, but an enum can say a lot more than it tells by itself, its state, rather than having to deduce what exactly, if it's positive or negative meaning of Boolean that represents the value, and can combine different several Booleans in one, so that you have like active and enabled, and you can have 3 enums value instead. What would you think about that, Szymon? Is it a good pattern or something that is not worth your time?
Yes, that's good. Actually, this talk has in title how to improve the state machines, but it wasn't about that. It was only the analogy. But yes, it's always good to group together and protect the correct values of a type or state. We can always create or even structures of if we don't have like single value, which is for the state, like in enum, we can also bind together more things in the structure. Yes, so I think it's good tip.
And something about git blame, as I noticed that I don't think we have a git blame ignore revision file. So it's a file that you can put in your repository to just say that, oh, those commits are just refactoring, so I don't want or formatting code, so I don't want to see them in git blame, so that when you explore things with git blame or git lens, you don't see those commits, and those are very useful. Hence, formatting commits are not that common, so maybe the need hasn't been really strong for that so far. You know about those, Szymon? Any idea?
I'm sorry, I didn't hear well
I
what you said.
was talking about git blame ignore revision files. So that's a file that you can put in your repository to say explicitly that some commits should be ignored in git blame by git blame, and then you can give the file name to git blame when you run, but it can be enabled by default if the repository has the right configuration to point to the file.
Yes, it also sounds good.
Well, that will be enough.
Okay, thank you, Mevan. Mike?
Yes, do you hear me? I have not a question, but rather a comment about a combination of documentation. You mentioned that commands are documentation and unit tests are documentation. And I wanted to notice that we need to combine them because unit tests need their own commands and good commands also. Because when you write the unit test, you usually know, you see very well what you are testing. But after a while, you or someone else could have a problem that some change broke the unit test because it now, for instance, gives one off value. And it is a question if this one off okay, or is it exactly what the unit test checks? Maybe it would be also okay if it would be 5 off, 5 point off. And only after some threshold it would be really broken. So, of course, you can't see everything in advance, but having a good command describing in human words what you are testing and why you expect it to be so and so is also very important in unit tests. Thank you very much.
Yes, good point. The unit tests are also the code, so probably all the rules apply to them too. Yes, so good to have also the documentation for unit tests. Thank you, Mike.
Thank you, Mike. Thank you, Szymon. Miklos?
I would have just two short comments. First is that this git blame ignoring revisions is something that we actually do use on the core side. When something was reformatted with clang format, then some of those commits are collected there. So it's there on the core side in case there is some similar problems on the online side that some commit is really just mechanical reformatting, and it was done. Then we could collect those there. The other thing is that you mentioned these kind of code owners when you kind of own some file. I think it's good to care about code. So that's in case that gives you some extra notification that it was updated and changed, and you can go there and read it and perhaps came up with helpful comment in case something is fishy there. That's all good. But at least back in the OpenOffice times, there was this trouble that everything was built around these code owners, and everyone tried to work around things locally because talking to the code owner was something very dangerous, and you might provoke the dragon. So it's something that we actively try to avoid on the LibreOffice side, and probably we also want to avoid in online. So in case you say that something you find the right place to fix your problem, and you think technically that's the right place to fix it, then don't worry if this is not your code. It's let's not like take these code ownerships and too seriously. It's of course good to know that somebody is knowledgeable about something, but we are all here to build a great project, and it's not about creating something that would be your pet thing, and then later nobody can touch because it's mine. So let's try to avoid building this kind of catch-all. Thanks.
Yes. I wanted to mention that only as a tool to like see what happens there, as it's easier to understand your own code, so you can at least have some easy code you can in which you can notice things, how to improve them or group together, because oh, there was something similar I already have, not something like that person has to approve all the changes there. Thank you.
Makes sense.
Thank you, Miklos. Pranam? Raj? Samuel? Okay. Thank you, everyone. See you next week, and bye-bye.
Bye.